Hello friends, welcome to Quickfire Numerical Solving Series for GATE 2021. We'll discuss numericals based upon amplitude modulation with full carrier today. I've written down the key formulas to be used in solving such numericals, so you could pause the video and note down these key formulas first, and I'll assume that you already know what amplitude modulation is. So I'll not go into any of the details of the theory. I'll straight away tell you how to implement the formulas in different scenarios of questions. So let's get straight into this. When we talk about key formulas, the first key formula is the modulation index, which is given by MA, because this is amplitude modulation, so subscript is A, and this is nothing but the amplitude of the modulating signal upon the amplitude of the carrier signal. And then we have the power in the carrier signal, which is AC square upon 2. The modulating signal will look something like this. It is a sinusoidal function, and the carrier signal is also a sinusoidal function. So this value that I'm talking about is AC, and this value that I'm talking about is AM. So you could note down that this is going to be AM and this is going to be AC. From the journal equations, you can simply deduce the values of AM and AC. So this is going to be the power in the carrier signal. This is going to be the total power. Now see, this total power is equivalent to the power in the carrier and PC multiplied by MA square by 2, and this thing is the power carried by the double sideband of the signal, and in other words, this is the power of the modulating signal also. And the next formula is simply this thing. So you could say that my total power is the power in the carrier plus the power in the double sideband, and the power in the single sideband is half of this. So you could remember this by simply deducing that a single sideband would have half the power of a double sideband. Then we have the efficiency, which is MA square upon 2 plus MA square. MA is calculated in the first step, which is the modulation index. So efficiency is calculated in terms of modulation index. Another formula to calculate efficiency is the power in the double sideband upon the total power. So this is another way of expressing efficiency. And then we could express the modulating index in terms of a percentage by multiplying it with 100%, because in this case modulation index will always be lesser than 1. For values greater than 1, it is going to be an overmodulated signal. Again, theory, which I'm not going to get into. And the total power in terms of the maximum amplitudes of MT and CT can also be expressed as this, because this is nothing but PC and this is nothing but the power in the double sideband. So M average of MT square upon 2. Now the reason I've mentioned this formula here is because even if your modulating signal is not a sinusoidal wave, it could be a triangular wave or a square wave, then you could simply calculate the average power upon 2 as the power in the double sideband. Rest everything will remain the same. All the other formulas can be used as they are. It's just that you need to substitute the value of the average power in the modulating signal here to get the value of total power, and MT is again AM square by 2. You could substitute it here, so this will become MT square by 4. Well, these were the key formulas that are needed to be used here, and you need to commit to your memory to solve these kind of numericals. Now let's look at this numerical where MT is given, which is the modulating signal, CT is given, which is the carrier signal, and you need to find the modulated signal. So the modulated signal is always given by MD and it is nothing but AC cos omega t omega ct plus AM sin omega tm into cos of omega ct. So you could simply multiply these two things. So this will become 8 cos 6 into 10 raised to the power 5 t plus 4 sine 2 into 10 raised to the power 3 t, and then cos of 6 into 10 raised to the power 5 t. So this is going to be your modulated signal. And now let's talk about AM here. AM is 4 here, AC is 8 here. So what can we do here? We can first find MA, which is nothing but their ratio. So MA is going to be 4 by 8, which is 1 by 2, and MA is going to be used in a lot of places, for example here. So we need to calculate PC now in order to calculate total power, and MA is now calculated. Modulation index is half, 0.5. So let's calculate PC. PC is AC square by 2, AC is 8. So 8 square by 2 is 32 watt. And my total power is going to be, total power is PC 32 plus 32 into half square by 2. And this is going to be equivalent to 36. Now we know that PT is the sum of power in the carrier plus power in the double side band. So my total power is 36. So power in DSP will be 4. You could put 36 here. 32 is the power in the carrier. So power in double side band will be 4 watts. And this is 36 watts. So you can see our carrier carries a lot more power than the actual signal's power. Power of double sideband is a representative of the power carried by the signal itself, and PC is the power required to transmit the carrier signal along with the modulating signal. So this is what we have, and P single sideband will be half of this, so this will be 2 watts. Now everything looks pretty simple. Eta can be found using this formula, so I can put half square upon 2 plus half square. So this is going to be 1 by 4 upon 2 plus 1 by 4, and that should give me 1 by 9 as my efficiency. So efficiency is pretty low. You could see the efficiency from here also. It is the power of 4 by 36 again, which is 1 by 9. I told you this is another method of finding the efficiency, power in the double sideband upon total power. So total power was 36, power in double sideband was 4, so my efficiency is 1 by 9. So that is how you can calculate anything and everything that is asked in a question like this. Now let's look at another question. In this question you'll see that the total power of the modulated signal is given as 9 watt, and my carrier signal is also given. I can calculate the power in the carrier signal using this formula. AC square by 2, AC is 4, so 4 square is 16 by 2 is 8. So I know that total power is PC plus P double sideband So this total power has the value 9 and PC is come out to be 8. So my power in double side band comes out to be 1. Okay, now from PDSP I can find modulation index. So 1 is going to be equivalent to 8 into MA square by 2. So this is going to be 1 by 4 is equal to MA square, and modulation index again has come out to be equivalent to half. Okay, how cool is that? And that's about it. Percentage of modulation is 100 of this, so 50% will be percentage of modulation. Eta can also be found. Eta is again half, like we did in the previous question. And can we found AM now? Yes, we can find AM, because MA is AM upon AC. MA is known as half, AM, AC is 4, so AM is 2. Great. So that's how you can find all the things which were asked in this question as well. Now let's look at another question. And in this question, PC is given. Good. And we know that the total power is PC. This is PC and PDSP. Now, but PDSP is not given. PSSP is given. PDSP is twice of this. So I'll put a 2 here. So my total is 66 watt. So total power is 66 watt. MA can be found from this. PC is 64. So this is going to be 66 is equal to 64 plus 64 into MA square upon 2. So this is 2 upon 32 is MA square, so it is 1 by 4. So MA is 1 by 4. Modulation index is 1 by 4. You could use any of these two formulas. I used this formula, but it eventually turned out to be this, because when 64 went the other side, so this becomes this formula. But anyhow, then we need to find efficiency. Once we know MA, we could easily find it. 1 by 4 square upon 2 plus 1 by 4 square. This is 1 by 16 upon 2 plus 1 by 16. So this 16, 32, 33. So this is 1 by 33. Just look at the calculation part, but you simply need to use this formula because MA is known. MA is 1 by 4. Modulation index is 1 by 4. So more or less all the questions based on amplitude modulation for full carrier are covered using these key formulas. You simply need to remember that modulation index is supremely important. It features in the total powers formula, in the double sidebands formula, in the efficiencies formula, and yes, MT, power of the average power of the ting signal. So these are the key formulas. You could commit these to your memory, make a ready reckoner of these, and be ready for the gate examination. So that was it for today's tutorial. I hope you liked it. If you did, give it a thumbs up, and all your support is appreciated. I'll see you around in the next video. Take care. Bye bye.